Hi guys, I'm Griffith from period 1 of Mr. Farrar's Algebra Pre-Calculus class, and this video is on Riemann sums and definite integrals, which is lesson 6.3 of, chapter 6, lesson 3. And so a really handy thing to have would be lesson 6.2. It's got this list of theorem 6.2, the summation formulas, which are going to be critical for solving Riemann sums problems, because, if you're like me, you've probably forgotten these, so it's just handy to have the sheet out. So Riemann sums, previously what we've been doing is we've had a curvy graph, and what we've had to do is had to estimate the area of underneath the curve by doing underestimates and overestimates. We've been doing the two, starting from the left endpoint and the right endpoint. But with Riemann sums, we're able to calculate the total area from A to B, or infinite, if we use that n, by going and making the width of the rectangles, the delta x, increasingly smaller, and it becomes an infinite number of points, which allow us to calculate the area underneath the curve. So what the formula for Riemann sum is going to be summation with n and I equals 1, f of c of I, and so the function times the change in x. So sum of all that. And it is equal to the definite integral, which is the b to a f of x d of x. So what the limit of the x as it approaches 0. So what this means right here is that as the x value in between the as the delta x decreases and gradually becomes 0, this provides the sum for the area, and you will end up getting the limit as n approaches infinity, because you'll have an infinite number of rectangles within the area. Alright guys, so that was just a brief little look at what they are. So now I'm going to do a practice problem for a Riemann sum theorem. So if we're given the definite integral from 5 to 0, this is just a really basic one. I have harder ones on my practice worksheet. What we're going to do is, the first thing we're going to find is delta x, which is equal to b minus a over n. And in this case, it's going to be 5, because remember, this is b, this is a, so it'll be 5 over n. Afterwards, we're going to go and we're going to find c. So in all cases, it's going to be a plus delta x times I, and the i's, remember, they're part of the summation formula, so they're really important and we have to know those. And so in this case, we're going to get 0 plus 5i over n. So this is a really super simple one. And then the next step is we have to plug it back into the original equation, which in this case it's just 4x. So all it is 5i over n is going to represent our x, so we get 20i over n. The next step is to go and to plug it in to the summation formula. So let's write it all out. N I equals 1 of f of c. Later we're going to multiply it by the change of x, but for now let's just hold off on that. So this is part C, part B, part A. So let's see, we have 20 over n, and remember I is n times n plus 1 over 2. So I had forgotten this earlier, so that's why you need the 6.2 summation formulas. So we can cancel this out, 10. So we get 10n plus 10. Next up, it's called E, is to multiply what we just got by delta x. So we'll have delta x and summation formula. I really don't want Kevin to write those. I'm sure you don't either. And you get 5 over n times 10n plus 10, which gives us 50 plus 50 over n. The final step is to go and find the limit, which will give us the total area in the segment from 0 to 5. So what we have to do is the limit as n approaches infinity, because we'll have an infinite number of rectangles underneath the curve, of, and the whole equation, x 1 delta x times f of c, which equals the limit as n approaches infinity of 50 plus 50 over n. So when we take the limit, you get 50 plus 50 over infinity, which tends towards 0. So your answer for this question is 50. There you go, you can see it there. Alrighty, so another thing we can do with definite integrals, there are some properties which can be extremely useful, where you can go and you can have the integral of, from b to a of f of x dx, but that is equal to the integral of c to a of f of x dx plus the integral from c to b f of x dx. So what this basically means is that, we've got the graph, we've got the curve, let's say we have a and then b. Well, we can have this point c, it could be out here, and then, this one would be negative, and it would all equal out, it's the same. So basically we're saying a plus c, well, this section plus this section equals the entire section. So we can do some problems with those, and they'll often give us, from 5 to 0. This is problem 41 from page 418, which I'm going to do right now, if you want to go and look at it yourselves and follow along. So they'll give us, from 5 to 0, f of x. d of x equals 10, and from 7 to 5, f of x dx is equal to 3, and then they'll ask us to find certain things. So the easiest one to do would be from 0 to 7, f of x dx is equal to, this is the easiest one to do because, it follows along perfectly with a to c, c to b. So here we have 0 to 5 is 10. Multiplying it, adding it to 5 to 7. And so the answer is just 13. Super easy. That's part A. So part B is asking from 0 to 5, f of x dx. And so another property of integrals is that if you want to flip the order they go in, instead of being a to b, you want it to be b on the bottom and a on top, you just put a negative sign out front. And so we're already given that from 0 to 5 it's 10, so from 5 to 0 it's going to be negative 10. And then C is just saying from 5 to 5 f of x dx. So we can again use our knowledge of a to c, c to b, and we'll start off with the 5 to 0, so that would be negative 10. We're going to add 10, so that's just 0. So finally we have part D. I'm just going to have 5 to 0 of 3f of x dx. So here we're just multiplying it. Check out the properties of definite integrals in your notes. They're very handy. So building on this, you can use definite integrals to solve much more complex problems using U substitution. And I put one of those problems on my practice quiz. And they're very simple. We're going over them right now in Unit 8 because they help us a lot. So I don't think I need to explain those, but they are based on these, and it's extremely helpful. So that was Riemann sums, and I never showed you the last one. Oops. And definite integrals.